Assalamu alaikum. Welcome to my new video. It is basically related to unconfined compression test. This test is most commonly conducted on clay type materials. So this is the quick test used to determine the undrained shear strength and undrained cohesion. Undrained word means the due to quickness of the test, the water inside the sample does not have time to drain out. So as per Coulomb formula, shear strength, this is the basically the Coulomb formula for the shear strength. During this test we assume that internal friction is equal to 0, so SU equal to CU. So Cu is basically the undrained cohesion and Qu is the stress. Find out from dividing the force divided by the area. So Qu divided by 2 is the unconfined compression strength. The apparatus required for this test is the UCS apparatus. This is a basically advanced one which is basically used for the FYP and research purposes. This is the mold used for the preparation of the sample of the disturb. This is the balance, spatula, wash bottle, china dish. Procedure for this test is you need to, for disturb sample you need to prepare the sample according to the MTT and OMC achieved from the Proctor's test on in both disturbed and undisturbed sample. First of all, you need to note down the dia and length of the sample. Then you need to put down the sample into the UCS machine. UCS machine have two gauges. One is the loading ring which show the force values, while the vertical displacement gauge. Here before the starting test you need to set down both these gauges at 0, and as you need to note down the force values at these displacement intervals. Graph and table. This is the basically table showing the sample length, sample dia, borehole, depth of the sample achieved from the borehole. During the test we need note down these two values. One is the deformation values and other one is the force values from the proving ring gauge. So this is the deformation dial reading which can be find out by multiplying the least count with the deformation values. So this column can be achieved, and this is the basically the change in this is the basically strain achieved by deformation dial gauge reading divided by the original length of the sample. This is the cross-sectional area find out by pi r square formula. This is the force value noted down from the gauge. This is the stress find out by dividing the force value divided by cross-sectional area. This is the other stress values in different units. So here as you can see that the graph is basically showing the stress divided by strain. So this is the basically stress values and this is the basically the strain values. So as you can see that SU, as I mentioned in the start, this is the basically QU, this is the peak for example. So at that point this is the basically peak highlighted by the red color. So at that point we have 1063.3 pound per feet square Cu. So this value divided by 2. So this is the basically Cu and Su shear strength and undrained shear strength and undrained cohesion. value. This is the point. So this is the basically this type of apparatus is basically used for the at BS levels. This is the basically proving ring attached to the dial gauge showing the force values, and this is the basically vertical displacement gauge. So before the start of test you need to set down both these values, both these gauges at 0. So there is another graph can be produced during this test, which I show now. So this is the basically normal stress, x-axis along normal stress, and normal stress. Uh, as you can see that force is applied from the top and bottom. So every geotechnical machine is designed this way that it start moving from the bottom side. So as this is your soil sample, so this is from this direction and this direction, which is the sigma one, and also from that direction here sigma 3, which is basically the confining pressure is 0. What is 0? So this is the point of sigma 1, which is equal to QU. So QU, I have shown that this is the basically QU point, which is divided by 2. So this is the SU and CU value. What is the SU and CU? This is the basically CU and SU value. CU and SU, which is basically half of the stress of the sample. So advantages of this test is it is very simple, quick and convenient test conducted on saturated clay type and intact sample. This one advantages is friction angle is considered 0, which is unrealistic. Test cannot be conducted on coarse grained and fissured clay, and produce low value of Cu due to the lack of confining pressure and non-saturation of the samples, and also the disturbance of the sample. So this is the basically the unconfined compression test, which I have discussed in my video. Thank you for watching my video, and subscribe my channel. Allah Hafiz.